What up, guys? Welcome back. I believe today's episode 98. We're so close to 100. What a milestone that'll be. Episode 100. And you know, we're only going to keep going. And yeah. Today, we got a crabby today. So we're going to check out the sound. I decided we're going to do a little bit of motivation at the beginning of the video, because I feel like I do need some motivation. Yeah, like, you know, getting to episode 98, obviously, you know, that's a lot of hours to do Leetcode. Not that I don't enjoy it, but I do enjoy it, but it's still like, you know, it's still a grind, you know what I mean? Like, I guess, but anyway, let's take a look at the sound really quick. We got Pixelmon here, then. Let's check out the Pixelmon sound. Probably. There's our crabby. Let's finish it. This guy says cookie. Cookie. The new Oreo advertising is lit. Alright, last one. Alright, there is our sound of the day. Let's take a look at some motivation. I got this TikTok the other day with some motivational quotes, and it kind of inspired me to kind of do it at the beginning of the video, so maybe I might read a new motivational quote of the day. Alright, here we go. Here is our quote of the day, starting from today, episode 98. Success is not final. Failure is not fatal. It is the courage to continue that counts. What a beautiful quote. Beautiful quote by Winston Churchill. Success is not final. Failure is not fatal. It is the courage to continue that counts. And I feel like that is very important. You know, we were very close to a job. Very, very close to a job in an internship, might I say, in a couple months ago. About a month ago, actually. Maybe a little bit longer than a month, but, you know, there's some rules. You know, they didn't allow me to do the internship because I am on a visa, and that is fine. But, you know, eventually our opportunity will come. You know, it just wasn't meant to be, and, you know, that opportunity will come. So we're going to continue. I don't know why I'm on chess.com. I have been playing chess. I am not that good. I am only nearly 700 rated, so I've just kind of started, but we're going to be grinding. Yeah. Let's take a look. Let's take a look at our Leetcode problem of the day. So we got an easy problem today. Maybe we'll take a look at it. Maybe we've solved it already. No, we have not. Given a zero index array nums of length n and integer k, return the number of pairs ij where 0 is less than I is less than j is less than n, such that nums I is equal to j and I times j is divisible by k. Jeez, man. So much crap, dude. Okay. I believe we should be able to do this simply with, you know, the brute force solution, just a double for loop here for j in range, and then we need I plus 1 length of nums, right? Because it says here that I has to be greater than 0, j has to be greater than I, but it can't be greater than n, right? So that satisfies our first condition. Then we need to check, well, we need to check if nums I is equal to nums j. So nums I is 3. 1, 2, 3, 4, 5. And nums 6 is equal to 3 as well. Okay, so we check, well, if nums I is equal to nums j, then, and I times j is divisible by k. And let's do I times j is divisible by k. So is that if we get divisible by k? So if we get it 0, right? So we probably want to do modulus. And I times j modulus 2 is equal to 0. Then we simply want to count. Count plus or equal to 1, right? And we'd want to return our count. Count variable out here. Count plus or equal to 1. Can I access local variable count where it's not associated with the value? Oh, why did I do count is equal plus equal 1? Count is equal to 0. There we go. There is our brute force solution right there. Pretty straightforward. Oh, nope. No, 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 no. What is wrong? Output is 35, but the expected is 18. Are we missing something? Given a 0 index, integer array nums of length n, and integer k, return the number of pairs I and j where 0 is less than I is less than j is less than n, such that nums I is equal to j and nums I. 2, 3, 2, 4, 3, 4. Since no value of its nums is repeated, they're on. I is less than j. And I times j is divisible by k. Oh, whoops. I had 2 here. I think that's why. Ow. There we go. There's our submission of the day, baby. Is there a faster solution though? We didn't actually look. There is a faster solution. What is that solution? What the fuck is this, dude? Count divisible products. Bro, what is this solution? What a default dictionary, dude? What the? Bro, what is going on here, dude? Looks like here the fast solution is over n squared. You need an n squared solution. Is there anything faster? The urge to solve an easy with brute force is so high. Anyway, let's just move on to our next problem. We were looking at backtracking yesterday. I'd say we did okay. I mean, I would have liked to probably get some of those questions I have done in the past. But, you know, it's okay. You know, shit happens. So, I guess we'll go straight back into it. We'll check out our subsets 2 problem. Let's take a look. I'm going to grab actually a quick snack while this loads really quick. We have not solved this one, so interesting problem. I'll be back. I'm going to grab a snack and we will do this problem. 1 second. show the camera what we got here. Some like sugar eggs, dude. My mom sent them to me from Australia. I love these when I grow up. I'm not a big chocolate fan, so I always like the sugar eggs better. It's probably so bad for you, man. There's so much sugar in this, bro. It's insane. Like, oh. Let's do another sugar egg for now. Start with our problem, right? This problem does look very similar to subsets. Alright, that's what I was thinking. What's the difference? Given an integer nums that may contain duplicates, return all possible subsets. That may contain duplicates. Alright. I'm not going to look at the code here and instantly reset it. Of unique elements, return all possible subsets. All right. Unique. So what's the difference? If there's duplicate or not duplicate results, right? Like, isn't it the same thing? Oh, wait. 1, 2. Oh, okay. So if it's already in there, then we don't add it. What would be our base case here? Shit, man. What would be our base case? Shit, man. What did I use as the base case for this one, bro? I don't remember. What is the base case? That's probably not a good thing. What is the base case? What did I use? If index is equal to nums. If index is equal to length nums. Why is it if index is equal to length nums again? It's because... Okay. So we need to do res.append. We append our return. Res is equal to... Right, we would want to go, okay, well... code.append. We'd want to append our current value, right? So it would be... need nothing down here. Call our function with our index value, right? Probably we need to pass in our cur too, I think. We return our res. Pass in our cur. Append index. Then we probably want to do, okay, well, I just published some ASMR right now. Maximum recursion depth exceeded, man. Okay. I think we're going to need, well, if index is greater than like nums, then we'd simply just return, right? All right, hang on. Maximum recursion depth exceeded. Bro, what the hell is going on? Maybe this is definitely not the best way to do it. Maybe it's, we use a for loop for I in range length nums. Cur.append nums index, right? Then we call our backtracking function, backtrack. Cur, and then we pop. Bro, why do we get nothing in there, bro? Like, what? Index is greater than the length. Where's that append cur? Oh, sorry. We just want to return. What the Okay. Let's go through this code, right? Pass no index, 0 and cur. We go for I and range length num, starting from 0, right? I and range length nums. Nums index. Backtrack index plus marker. That's exactly what I did, bro. What the hell is this? Man, I hate these backtracking problems, dude. They piss me off. Oh my god, dude. That was my reason, bro. Oh, finally, bro. Oh my gosh, dude. I was like, what the hell is going on here? Man, I'm getting a little tired. I'm reading orders board check. Take a look at yesterday's problem. It was permutations. No. Was it? Permutations, Leetcode. No, we don't want the length occur, right? That was our trick, right? If nums I incur. That was getting... Let's make this start. Maybe it says here we don't really need a base case, right? Because you want every value except for the ones that we already have in there, right? So sorting it handles the duplicates, right? Because we don't need. Pi is greater than start, and num's I minus 1. We can just continue. Cut out the pen, num's I. If I is equal to length times, if DS not an AND. No way, bro. I feel like this is the way I think about my recursive functions, right? If I don't want to think about it in the way, if index is equal to start, if index is equal to the length of nums, right? We would append our cur, right? Base case, right? Okay. Then we go, okay, well, code not in res, we would append. Okay. We do our simple recursive case, right? So we'll code.append nums index cur dot backtracking cur by backtracking index plus 1 cur dot pop backtracking index plus 1 cur. Backtrack 0 empty string return res. Nums index is out of range. Index is greater than the length of nums. Why don't I think about it this way, bro? Tell me. Like, if code not in res. Literally yesterday, to avoid the duplicates, I used a set. Might as well not even use a set. Would it have passed yesterday's problem? I don't know. I really don't know. Let's try this. Res. So we want, give a collection of candidates and target num target. Find all unique combinations in candidates where candidate num is shown to target. Oh. Okay, here we were summing though. I don't know, maybe it might still work, I don't know. Def backtrack. We want to pass in our index. Pass in our cur, right? In this case here, our base case would be, well, if target is equal to the sum of cur, then we know, okay, res.append cur, we return, right? Need to make sure we append the copy, right? We want to check, well, if cur not in res, and code.copy, right? And we do, okay, our recursive case, right? If index is greater than the length of candidates, index Sorry, we want less, right? We would do okay. Code auto append. Candidates index. We call our backtracking function. We backtrack index and cur. Plus one and cur. Cur.pop. We backtrack index plus one cur. And we want to return. We want to call our backtrack cur 0 and return res. Sorry. 0 empty string, empty array. One two five 1 7 7 1. Right, this is where I had my issue, right? Maybe we have to sort here. Res.sort. Oh, sorry. Candidates.sort. Time complexity because of the sum cur. Yeah. TLE. TLE because of the sum cur. That's why here we use the for loop. Alright, well. Take a look at word search. I've done this one. And it was December 22nd, 2024. I was in Australia then. I feel like this could be a DFS problem too. Yeah. Whoa. You're an Indian hire. God, that's enough sugar for me for today. Oh my god. Okay, let's do rows is equal to length rows. Cols is equal to length. Right? Okay. Okay, let's go. Okay, well, for I in range length nums, I in range length board, right? We can go, okay, for J in range length board. Sorry, let's go for row and for col. Here you go. Okay, we can just do rows here. In range cols, right? Guess we're probably gonna need a backtracking function, right? Over here, right? In here, we're gonna pass in, okay, well, we need to do an if, and we need to check, okay, well, if it's equal to the first element in our thing, that's when we can begin our search, right? So if well, if board row col is equal to word 0, then we can begin, right? We can begin our backtracking, right? So we will call backtrack. We'd want to pass in our row and our column, and then probably like row call like word 0 plus 1. I feel like there's a better way to do this. I don't know. So row call index. Okay, so we get into our backtracking function. We go, okay, well, I'm gonna need a directions array, right? So directions is equal to, well, to go, we need a up, down, left, and right. So we would go, okay, well, what would up be? Up would be 0, minus 1, right? Down would be 0, 1. Left would be minus 1. And then right would be 1, 0. Right? We probably want to start looping from that this specific element, right? So what would that be? Oh, microphones all fucked up. Hope that kind of fixed it. Anyway. Let's do like a cur or something, right? We can do some sort of like cur is equal to this. Passing in the value, right? We'd want to pass in, well, maybe we'd want to pass in 1. I guess our base case would be, well, if cur, the length of cur is equal to the length of the word, right? We want to do, well, we would just want to return true, right? Now, recursive case would be, well, we'd want to go, well, for row length rows for coal in range length coals. No. No, we don't need to keep looping. We need to check. Okay, well, for row call in new row, new call in directions. So new row is equal to row plus dr. Then call is, sorry, new call is call plus dc, yeah. Check, well, if new row is equal to, if new row is equal to if new row is less than or equal to NC the length of rows, and we have to check the bounds is less than, sorry, this is meant to be new row, new call is less than the length of columns, and or new row, new call is equal to word index, right? Then we can backtrack from that point again, right? Then we can call the backtracking function and backtrack from row call, sorry, new row, new call, out index plus 1, and our cur, right? Do well if this, then we can just return true, right? Okay, so we can do, well, if this, we can just return true, else we would just return false. always get through all this. We just return false, right? There's gonna be some issue in this code here, 100%, but I haven't even ran it once. Yeah. We don't need the length of rows. Less than rows. What is less than cols? String is out of range. Okay, if it's out of range, I guess we'd want to return false, right? Well, no, actually. I guess we get through all of this. We'd want to return false. What? Ooh. Really, really close to manage is how you're tracking visited cells and how you're managing the cur list. You never mark a cell as visited. We need a visited. Ooh, we totally forgot about that, bro. Base case, we find the word, right? Out of bounds or character mismatch if technically, yeah, we don't need a cur, right? Because we're just returning true or returning false. Let's do a visited, right? We can create a visited set. Oh, we have a new set every time, right? Set. Okay, right. We're gonna get rid of this. We're gonna do, okay. NC index +1. We want visited, right? We return true. Okay. Then we want to check here, we want to check our bounds, right? So we would check, well, if row is less than 0, or row is greater than or equal to rows, or col is less than 0. Sorry, it shouldn't be. If 0 is less than or equal to rows, but is less than the length, but is less than rows, and 0 is less than or equal to cols, but is less than cols, and we want to check, well, I think this is or, because we're checking false, right? Or row call in visited, or board row call actually, no, let's not do it this way. I don't like this way. I'm gonna do it my way. Okay, if but it's less than rows and 0 is less than or equal to col, but is less than cols, and visited, and okay, let's do and new row, new col, not in visited, new row, new col, not in visited, and board nr nc board nr nc is equal to index yes, we do board index +1. Then we do well, if backtrack, we would return true, right? For the recursive, we want to do visitor.add row call Yeah. Okay, we do our recursive. We would return true. Otherwise, we have to remove from visited. Visited.remove row call. Turn false. Let's see if this runs. String index is out of range. I think we're getting an index out of range because we're passing in 0 here, right? And then eventually we're going to go out of range. Really doesn't like it the way I did. Doesn't like it, bro. What is going on? Oh my god, dude. Why do we have a code append here still? Jeez, man. We can get rid of that stuff. Equal to word index plus 1. Then we update our base case to make it length of word minus 1, but we just did that. That didn't work. I know this is the issue. Visitor.add. And we go. We loop through. Check our if. 0 is less than or equal to. Oh shit! We're checking the wrong one. And R and C. That might be why it didn't run. And C not invisited and border RC is equal to word index plus 1. If backtrack NRNC index plus 1 visited return true visited.remove false. We loop through. I think this might run, but I don't know if it'll pass all test cases. Does it pass all the test cases? I don't know. Oh, bro, do we really? Oh, thank God it passed, dude. How did we do this last time, dude? Oh my God, we did DFS, dude. Jesus.
On your own personal brand. Just keep in mind, these people that are making for someone to want to get the urge to build themselves from the bottom up with all of the repercussions involved. That means getting the right sleep, eating the right food, putting the right things first so that you can make it to the goal. Most people don't know how to see that far down the road and get misconstrued when they see no results at the beginning. So thoughts?
Okay, nice. Well, we solved that problem. That was definitely I mean, I feel like this backtracking function was so much easier, bro. I mean, bro, I pretty much had it. Like, I feel like what was my original submission? Like, it was the same thing, just without the visited set, right? Like, except maybe we had this indexing wrong, but other than that, we, thought about it like in the right way, which I'm really happy about. So, yeah, I think that's a good, solid problem. Now, do I want to do it the DFS way? I was going to. I don't know if I want to. I'll just kind of read this code. These are the directions, yeah. For R in range row, for C in range column. If board RC is equal to word 0, create our stack, right? We pass in our row, our column. I assume this is our index. I'm going to assume that's our index. And then we pass in our set, right? There was some crazy brackets going on here. It's a typical iterative DFS approach, right? While we have our stack, we pop everything. We check if it's equal to the distance, right? Which is what we did here. Well, it's not, right? And if it is, we would just return true. We check our neighbors, so we loop through our neighbors function over here, right? We create our variables, our next row, next column, right? We check if it's valid, right? If is valid, next row, next column, and visited, and board index, board row column is equal to word index plus 1, right? So our is valid here, I think, just checks the bounds and if it's in visited, right? So just a simple helper function. And then we check if board next row, next column is equal to word index plus 1, then new visited is equal to set visited. Check if within bounds and is the next letter. Add new point. I don't know why we create a new visited here. Why are we creating a new visited? I don't understand this part. Guess we can check if it's within bounds, right? Then we can add our next character, right? If it is, we would add it to our visited set. Pass in our new visited. I don't know why we're passing in a new visited every time. I guess we're just tracking the value before it, I assume, maybe. I don't know. I have no idea, but it's pretty much what I would have done. Yeah, how long have we been going for? That problem took a little bit. Oh, man. Okay. Let's jump into our next problem. We'll check out the palindrome partitioning, and maybe we might leave the phone number to yes. Palindrome partitioning. We haven't solved this, but we have solved the phone number one, I believe. Valid phone number is 27%. Jesus. Letter combinations of a phone number. I remember looking at this problem. It was a little while ago, but I remember looking at this problem. Given a string containing digits from 2 to 9 and inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. Okay. So it could be, we have solved this one. I'm going to leave the partitioning one to tomorrow. I think we'll leave this as our last problem of the day. This is probably going to take like, I don't know, a decent while. I mean, it was a long time ago we solved this, Jan 21, a few months ago, nearly 3 months ago. Given a string containing digits from 2 to I inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. A mapping of digits to letters, just like the telephone number buttons, is given below. Note that 1 does not map to any letters. Okay. So I'm thinking here, my intuition is here to use a hash map, right? We create a backtracking function, use a hash map, right? Have the numbers as the key, obviously, and then the values as A, B, and C. We would loop through each one, right? Add each, so 2 here could be A, B, or C, right? Oh, shit. It could be A, B, or C. Okay, so it could be A, D, right? So I guess we would add to what we have or something. Yeah, that's kind of my intuition. Do I think that's right? Maybe. I don't know. We do have a hash table here, so we were thinking correct. So we do need a hash map, right? I just wanted to make sure about that. I do know for sure that when I did solve this problem back in January, I definitely had some hints. So it's good that we kind of had that intuition for the hash map, right? I'm really happy about that. Okay, so let's declare our hash map, right? Let's declare, okay. I guess we need to pre-make this hash map, right? So given a string containing digits from 2 to I inclusive. Okay. So I guess we can pre-make this hash map, right? I mean, I don't think that's cheating. I'm going to get an AI to do this because I don't want to write all this crap. Create a hash map with keys as numbers and letter combinations as a list in Python. This is for... Let's see if it'll do it. Okay, perfect. It did do it. See, this is what this shit is coded for, bro. Like... Just verify to make sure this is correct. We got ABC, DEF, and then 9 is W, X, Y, and Z. Okay, right? So now we probably want to create our backtracking function, right? Pass in obviously we'd need an index, and we need, I think, some sort of res array, right? So probably a res array here. We probably want like a, probably need a curve of some sort, right? Current array. Let's loop through. Let's backtrack. Cur. Our index, we want to start at 0, obviously, and then we want our cur, right? Cur, we'd probably want to pass in an empty array, right? So our base case will be, well, I guess if index is equal to cur, right? I think it'd be cur minus 1 in this case, right? Then we want to do, well, res.append append cur, right? We can, our recursive case will be, okay, well, well, for neighbor in graph, neighbor in, let's call it graph. I'm kind of getting this into like a graph problem, but not really. In graph index, right? We'd want to append all of our numbers, right? First, we probably want to check if not cur, right? Cur is empty. First val, right? Then we'd want to do, okay, well, cur.append shit. Trying to think here. Well, AAA, BBB, CCC. I guess it depends on the length, right? So okay. I don't know. It could be 4 as well. That's the thing. For neighbor in graph index. If not cur, first val, cur.append. Trying to think here, bro. How can we do this? Given a string containing 2 inclusive, return all. What I'm confused about how we know how many numbers to generate, because I think 3 digits would be even bigger, bro. Like, Man, bro, I just don't know how to generate these numbers here. Hmm. That's strange. We don't get more than 4 digits. Hmm. I don't know, man. I don't know how we can generate these numbers. That's what I'm confused about. I just don't know how to generate the first set of numbers. I know what to do after. We keep looping through the neighbors. We add the values, but it's like, dude, how do we... Need a hint, bro. Sorry, this is meant to be the length of digits minus 1. it should be digits index. Maybe we have to pass in graph here, I think. Graph. Oh, why are we getting a key error here, dude? What the? Oh, it's because I need the int. String index out of range. What the, bro? String index out of range. What do they got here? I think I'm getting it out of range because we're looping through. We're not checking. Is this my issue, bro? Why am I getting the string index out of range, bro? What the hell is going on here? Passing in 0. There's no way this makes a difference, bro. Like, seriously. There's no way this makes a difference, bro. Like, no shot. Bro, why am I getting this error, bro? I'm getting actually so angry right now, dude. Do I really have to make this fucking if statement here? Will this help anything? Bro. This is insane. Like. Yeah, this is insane, bro. I don't know why it's doing this. It's pissed me off. Bro, what is the difference here? Base case here. If index is equal to the length of digits, res.append. Oh, we're not returning here, bro. Oh my god, that was my issue, dude. Oh my god. Oh my god, that was my issue the entire time, bro. That is insane, dude. A D A E A E F B D B E B F C D C. I believe we had all this, but res.append. Let's get rid of this bullshit. need the backtrack code up pop. Then we need to do the res.append. append. Join cutter copy, I believe. Damn, bro. This is a return statement, bro. I wasn't returning nothing. Shit was pissing me off. All right, guys. Oh my god, my microphone, dude. What is wrong with this, bro? All right, guys. Yeah, so we're gonna call there for today. We've been going for about an hour and 46 minutes. So appreciate you guys watching, and I will see you tomorrow.